Hello, and welcome to HashiConf 2016 here in scenic Napa, California. And hello to our friends all around the world watching on the live stream. We have an amazing few days here together, but I have a few announcements before we get started. My name is Seth, and I'm the Director of Technical Advocacy here at HashiCorp. I'll be your MC for this morning's keynote. If you have not already connected, the Wi-Fi information is shown on the screen behind me. The SSID is HashiConf, and the password is security first, all one word, all lowercase letters. Please, for the benefit of all attendees, turn off Dropbox and other large file sharing applications. And while you have those devices out, let's go ahead and turn that sound off. Please make sure all devices, laptops, smartphones, watches, iPads, iPad Airs, iPad Pros, e-readers, make sure all of those are on silent mode so we don't disrupt this morning's keynote and those around you. If you do choose to have your device out and you wish to tweet about the conference, please use the official conference hashtag, which is HashiConf. You can use this on Twitter, Instagram, and other social media. Please take a moment, if you have not already done so, to review the conference code of conduct posted on the website. The code of conduct details what behavior is and is not acceptable at HashiCorp events. You may also find anyone wearing a HashiCorp employee t-shirt if at any time you feel that conduct has been violated or if you just have a question. Our staff will be happy to assist in any way they can. With that, I would like to invite Mitchell Hashimoto, founder of HashiCorp, on stage to start this morning's keynote. Please give it up for Mitchell.
Thank you. Thank you. So a year ago, we had our first ever HashiConf in Portland, Oregon. With over 300 attendees, it was a massive success. Today, around the conference, I've seen many familiar faces, so welcome back. To those who are new, welcome to your first ever HashiConf. Over the next 2 days, we have almost 30 talks planned. These talks are given by users, customers, and HashiCorp employees, and cover all of our tooling. Yesterday, and new to HashiConf this year, we had a training day with 4 sold-out trainings on Vault, Terraform, and Consul. So perhaps needless to say, with the training speakers, users, and HashiCorp employees, you're surrounded by not only the foremost experts on our tooling, but also experts on running modern infrastructures. We hope you enjoy learning from each other as much as you hopefully learn from the talks here. So we've had a busy year since HashiConf last year, and I want to start by talking about the progress we've made in the past 12 months. So at HashiConf last year, we reported over 400,000 downloads per month across all our open source tooling. So since then, we've seen tremendous growth, and I'm happy to say that today, this year, we're seeing over 1 million downloads per month for our open source tools. That's over 250% growth in just 1 year. And while this is a cumulative number, each individual tool is up. In addition to open source growth, it is important to build a successful business. So I'm also happy to say that in addition to the download growth, it's coupled with equally impressive adoption in the enterprise, along with enterprise sales. The increased adoption led us to close our first 7-figure quarter last quarter. And on the slide are just a few of the hundreds of enterprises that are adopting our technology. I'm sure you recognize them. These companies in particular will be joining me on stage later today to talk about their experience using HashiCorp tools and working with HashiCorp. An important part of the sales and community growth is our growing list of partners. Technology and system integrator partners allow us to reach new technologies, new organizations, and new users that we otherwise couldn't. Some of these partners are specific to certain geographic regions, some are specific to industries, and some are specific to just certain technologies. To highlight a couple and give you examples of what these folks do, ReanCloud uses Terraform and Consul to help organizations adopt microservices and migrate to cloud environments. Their recommendation of Terraform and Consul in cloud environments specifically helps us reach users that we otherwise may not have. And Flux 7, as part of their DevOps consulting work, has developed a comprehensive program to educate users to use Vault in healthcare companies to meet HIPAA requirements in the cloud. So this not only helps educate new users on Vault, but also helps encourage Vault usage in the healthcare industry, which is a notoriously difficult industry to enter. So across the board, companies are leveraging HashiCorp technologies and partners to solve today's biggest challenges in modern infrastructure. Last year at HashiConf, we announced the partner program for the first time. And today we're announcing our newest extension to the partner program. So we have technology partners, we have system integrator partners, and today we also have training partners. Forest Technologies and Amazic are part of our new partner training network. These partners are fully certified by HashiCorp to run official training programs on select HashiCorp tooling. These partners will enable more developers, operators, and security professionals to integrate HashiCorp into their organizations. Thanks to our partner network, now including these training partners, it is easier than ever today to find resources to learn and adopt HashiCorp tooling, no matter what industry you may work in. And none of this would have been possible without the dedication of the employees at HashiCorp. As we've grown, it's been encouraging to see that every single employee wearing the HashiCorp logo cares deeply for both our users and our customers. And HashiCorp started with just 2 of us, and 2 years ago, we only had 6 employees, but actually last week, we hired our 50th employee. These employees help plan events, fix bugs faster, support customers, find new customers, grow our partner network, and much, much more. Needless to say, each person plays a really critical part in the growth of this company. And one of these employees actually happens to be our new CEO, David Mcdonald. We announced this publicly about a month ago, but while we announced it a month ago, Dave, in fact, joined us way back in May. But rather than just say what he is going to do and say the role that he's going into, he's been quietly leading by example, which is very much the HashiCorp way. He played an important role in the progress that I've shown you so far, and we're very proud and excited to have him as our CEO. Dave is present here at the conference, and you should be able to find him walking around. He's a very, very friendly person, so I encourage you to say hello and ask him any questions about his new role at HashiCorp. Adoption of HashiCorp tools has moved well beyond startups and amateurs and fun weekend projects into major enterprises. The amount of interest in our open source and enterprise has been tremendous. And as these enterprises build mission-critical applications on HashiCorp, we need to continue to invest responsibly to support them. So towards that goal, I'm very happy to announce that we've raised the Series B round of funding. The Series B was $24 million, led by GGV Capital, who are insiders. They've been faithful advisors to the company since our founding. They understand and support our vision, our process, our community, and we couldn't have asked for a better team to lead our Series B. Also participating is Mayfield, who led our Series A, True Ventures, who led our seed, and joining us as a new investor is Redpoint. We've proven a set of strategies around product, sales, and marketing, and this money will go towards each of those on the foundation that we've already built. And all of this growth, the progress, the Series B funding is here to support HashiCorp currently and in the future to build HashiCorp as the DevOps infrastructure company. Since our founding, we believe that the practices and technologies encouraged by DevOps are the way of the future, and we've been building towards that. Over the past 3 years, we've built a lot of technology. This technology then branches into a lot of different categories. And when you view this through the lens of trying to encourage DevOps best practices and DevOps workflows, the approach becomes very clear. We started as just the company that makes Vagrant. This tool bridged a gap between developers and operators. Operators could test configuration management. They could use that configuration management to build production-like environments that they could then give to developers to work in. Developers, in addition to using these development environments, could now tinker with and learn about servers in a very easy way. After that, a little bit after that, and after Packer as well, we released Surf and Console. And this was a bit of a surprising moment in the company's history. For those that viewed us as a developer tools company, this is completely understandable. In isolation, it looked like that. But we were thinking about a bigger picture that I'll be painting out here, a bigger picture surrounding DevOps. And so in this step, we moved from desktop developer-focused tooling into more runtime production-critical software. But like Vagrant, these tools also aim to try to bridge a gap. And these tools bridge the gap between, again, developers and operators, but in a different angle. So developers were now given a tool critical for microservice or highly service-oriented development. You get an API for service discovery, as well as an API for configuration and basic key value storage. Operators, on the other hand, got cloud-friendly, easy to operate and deploy software that they could use to support these service or app-heavy environments. And so we continued on the path of bridging these gaps and attempting to move towards better team alignment. And then last year, we released Vault. And Vault, again, raised a lot of questions. Why is the development/operator company making a security tool? But Vault, just like our other tools, bridges a gap. And this time, the gap it was bridging was between all three of development, operations, and security professionals. Security engineers with Vault could define policy and get a security-focused tool they could trust. Operators get another cloud-friendly, easy-to-operate and deploy piece of software. And developers get high-level APIs for working with secrets, encryption, certificates, and more. And this leads us to our view of DevOps. Our view of DevOps is 3 layers and aligning them together to work efficiently. And these 3 layers include security as a very critical part of it. So as an example, our tools try to bridge the gap and align multiple layers here. So Vagrant, for example, attempts to align the top 2 with development and operations, and Vault, starting at the security layer, aligns all 3. And we view this as one, and that's very, very important. This is our definition of DevOps from a people perspective, in that we must align developers, operators, and security professionals together in order to build and ship software. And like I said, this is our people perspective on who we must align. But our technology perspective, our formula is equally simple, and this is a technology perspective. We encourage a design aesthetic that is consistent no matter what DevOps category or layer you're fitting in the previous slide. So everything begins with our technology as infrastructure as code, whether it's a security policy, data center topology, deployment strategy, it should be described as code. This enables minimal knowledge loss, versioning, reduced human error, etc. This infrastructure as code then combines down into a single workflow on top of that. So whether you're targeting VMs, containers, one cloud provider or another, the workflow on top of that infrastructure as code you wrote should be the same. It's always a Vagrant up. It's always a Terraform plan. It's always a Terraform apply. It's always a Vault write, etc. After the workflow, it then branches out again into modular and open. One workflow should enable multiple targets on the other side, and that should be modular and open to encourage the community integrations. And the reason we bet on DevOps is because infrastructure is changing for everyone, and we believe the DevOps mentality and process is the right approach to supporting this new world. On this slide, we show what we view as the past, the future, and the foundational technologies which must support both the transition and the future. So in the past, what we call static architecture is monolithic applications running in private data centers that use primarily perimeter or network-based security. And what we're moving towards is what we call dynamic architectures, which are microservice-based architectures built on public clouds that now use zero trust or minimal trust security. And the foundational pieces of software you need to support this migration is a microservices runtime, hybrid infrastructure automation, and application-based security. And you need this to both support the future as well as the past, and this is what we're building. We build technology of the future that also includes a bridge to support your past. And so here we are today. HashiCorp is the DevOps infrastructure company. We build tools to align developers, operators, and security professionals, and our technology is built upon our Tau so that there's a predictable and consistent experience no matter which of our tools you use. But let's go back and let's talk more about the technology. Over the past 3 years, as I said, we've built a lot of technology. And we're definitely not short on any new ideas. But we do want to strike a balance between releasing new functionality and maturing existing functionality. So we made a very conscious decision in 2016 to mature and integrate our tooling together. As a result, all our tooling today is more stable, more enjoyable to use, and has become the solid foundation it needs to be to support the mission-critical workloads that our users and customers are trusting us with and that you'll learn about in just a second. And we want to talk about a couple of projects in particular and the progress we've made with them. But to do this, I'd actually like to invite on stage Armon Dadgar, co-founder and CTO of HashiCorp.
Thank you, and thanks, Mitchell. I'd like to start today by talking about Vault for a little bit. For those of you who are unfamiliar with Vault, it's our tool for doing secrets management. And the goal with Vault is really to provide a uniform API, whether you're accessing API credentials, database credentials, TLS certificates, or SSHing into a machine. We released Vault last April, and it's been adopted at a tremendous rate, unparalleled to our other tools. And what's become clear to us as we've seen it getting adopted by startups, large businesses, financial sector, and even the government, is that it's clearly filled a gap in industry. As we're seeing more and more organizations move to microservices, move to public cloud-based architectures, there's a pressing need to solve the secret management problem. And this is a gap that we've seen Vault fill. In the last year or so, there's been a total of 9 different Vault releases. This spans over 2,500 commits. And in addition to the work we've done, we've undergone 2 full external code audits working with the NCC group. The result of that is that there's been a tremendous number of new features and improvements that have come to Vault in the last year that we simply don't even have the time to talk about all of them today. That said, there are a few that I do want to spend some time to highlight. Something that we try and do with Vault and all of our open source projects is to spend time with our community members, our biggest users and customers, to really understand what is the next generation of challenge they're trying to solve and what are their biggest pain points and frustrations when using the tool. With Vault, this started before we even released the initial version. We worked with Groupon, one of our biggest users and partners, to understand their needs for application authorization against Vault. And we worked in conjunction with them to develop AppID, which was available at the launch of Vault. But since then, in working with our community and working with a broader range of customers, we found that this backend just wasn't flexible enough. It wasn't able to solve the delegation problem, so how do we allow multiple teams to delegate the management of their applications? How do we securely allow management of it when you have other sorts of workflows around secure introduction? And so we worked closely to redesign the AppID backend in a way that's much more flexible, much more secure, and supports delegation within an organization. And so this is the app role backend that has been recently released. The other very common complaint we hear is the challenge of integrating Vault natively in applications due to its use of client-side redirects. So when you're running Vault in a clustered HA mode, when a request hits the standby instances, it generates a client-side redirect to go and talk to the primary instance. The challenge with this is it means your SDKs and your applications have to be designed to deal with this. In addition, if you're deploying Vault behind a load balancer-based environment, it can be challenging because the load balancers can get in the way of the client-side redirects. So moving on in the future, what we're doing now is supporting native transparent request forwarding, much in the way Console works, much in the way Nomad works, so the request can hit any Vault server and it'll automatically forward to the appropriate active instance. Lastly, as more organizations are adopting Vault and trusting it with its most secret and most sensitive information, security assurance is very important to us. So something we've taken very seriously from the beginning is both secure coding practices internally, defensive programming, in-depth peer review, but also making sure we're working with external code auditors. So we've been working with ISEC and NCC Group from the very beginning. We've just completed the 3rd full external audit for them. And this is important for us to make sure that as you guys are all adopting Vault, that you feel that it's a secure code base. And part of this has just been coming from the draw of enterprises asking us to help them adopt Vault and help them understand the secret management problem. And what this has ultimately led to is these organizations asking for us to help them adopt it and make it easier to bring Vault to their organizations. So to that end, we're very excited to announce today the general availability of Vault Enterprise, which is targeting exactly those types of problems. What we've been trying to look at is what are the challenges around the workflows of adopting a tool like Vault, and how do we make it much simpler to bring those into an organization? So we're excited to show a little bit of it today. What this starts with for us is being able to manage multiple Vault clusters. When we initially designed Vault, our assumption was that you'd run a single organizational Vault cluster that you'd run in a multi-tenant way. And what we found is that people have many different use cases for Vault. Some people prefer to run a different Vault cluster per environment, like staging and production. Some people are running different Vault clusters per line of business. Some people are running multiple Vault clusters within a line of business for different use cases. And so as a result of this, there's a massive sprawl in terms of the number of vaults that need to be managed. And so it was important for us from the beginning to make sure we could support managing multiple vaults. And this starts at the very inception when we start Vault. Anyone who's played with Vault knows this starts with the initialization. So this can be done either with the default settings, or we can go in and expose all of the advanced settings of Vault to, for example, PGP encrypt our root unseal keys to the system. Once a cluster has been initialized, we can use Vault to do the unseal workflow, so we no longer have to VPN into each of these different environments to do the unseal. We can use the UI to manage all of the clusters at once. And in terms of managing all of the clusters, we can be alerted anytime a cluster is unsealed or unavailable or becomes unhealthy for some reason. So this helps us prevent a potential outage. We can ensure that the standbys are unsealed and ready to go so that we never have an outage in production. Once we have our vaults unsealed and initialized and running and healthy, we can also interact with them through the interface. So this has been a very common ask for us, is simplifying the user experience as they're interacting with a Vault on a day-to-day basis. Whether it's developers who need to get credentials out to make use of them, or whether it's operators trying to update the credentials, or security engineers trying to set the policy and view how the system is configured. So where this starts, as with everything with Vault, is authenticating against the system. Vault has to first know who you are, to understand what you have access to. And Vault is designed in a very modular way so that you can support many different types of backends that fit your organization, whether that's LDAP, Active Directory, other single sign-on systems. So similarly, the enterprise UI allows you to choose a variety of authentication mechanisms. This could be token-based, could be username password, could be GitHub or LDAP. It's flexible much in the way Vault itself is flexible. Once we've actually authenticated against the system, we get to interrogate it and interact with the system itself. So we can see what secrets or what backends are mounted. We can drill in to see the individual keys available in there, inspect the actual key values themselves. And in case we actually have the permission, if we're an operator or security professional, then we can edit the keys inline, create new keys, delete them if need be. And lastly, in sort of a worst-case break-glass scenario, we can seal our Vault. And that's all we have to show today for Vault Enterprise. It's designed to allow enterprises to bring it in and easily secure their global infrastructure. But I don't want you guys to just take our word for it. So now I'd like to invite John Mitchell from SAP Ariba to talk about why they're choosing Vault.
Thank you. Good morning. So some people know SAP. It's kind of a little company that's floating around. Ariba is a business procurement network, right? So it's kind of boring. The thing that makes it interesting is over $1 trillion of commerce is run through Ariba. So a lot of money. So we use, somewhere in here, we use Vault and Vault Enterprise to pull all of what Mitchell was just talking about in terms of creating a single workflow that ties developers, operators across generations of technology stacks. Ariba's been around for 20-something years. Right? In that 20 years, you can see somewhere up here, over 200 applications floating around. Right? That's a lot. Think big Java enterprise, right? Heavyweight, the whole notion of a large monolith. It's accreted over generations. And we're making this transition, right, to microservices, container-based solutions, all of the stuff everybody in this room kind of already gets, right? But in that transition, we're creating, 1,000 microservices over the next couple of years. That's kind of non-trivial as well. So you've got old stack, new stack, different technologies, different generations. You've got something on the order of 1,000 users, developers, somewhere in here, across the company, right? Worldwide, speaking different languages, different cultures, all of that. So you can't just say, hey, we're going to try and train everybody up on these modern security principles. And you have to hide it, right? We have to encapsulate it. We have to extract it. And so Vault gives us a lot of ability to do the right thing for security and auditing purposes and whatnot. We've got various groups, right? The operations teams that has to deal with this is really around 50-ish people, multiple time zones. The part that I run into a lot is actually the various security people. Right? I think we all have that. If we work at any kind of enterprise, is you got to deal with compliance. You got to deal with audits. Right? You got to deal with all these policies. Good, bad, indifferent, doesn't really matter. It's just kind of the physics of a big enterprise. And so it's another way where we can take this bundle of different use cases and different interactions and different workflows and actually make it simple. Right? By creating and using Vault as a service, right, we can tie it into our build tools, our deployment tools, our different runtime tools. The auditors can come in and look at the audit logs. And all those kinds of things makes it very easy for people to understand how they interact with it when they're building their microservices. Right? We can build those abstractions in. And I think that's the most interesting thing about Vault for our use case is it just makes all of these complicated processes easy to hide. And with that, I'll invite Armon back up.
Thanks so much. Thanks, John. So with that, that's all I wanted to talk about on, the clickers. We lose our clicker here. Sorry about this. Let's see. I think someone check if the clicker is dead, or can we get the next? Thanks, perfect. Sorry about that. So that's all we wanted to talk about with Vault. That's what we have planned for Vault Enterprise. This is generally available today, and we're very excited to be able to show you guys. And with that, I'd like to move on and spend a little bit of time talking about Nomad. And the first thing I really want to talk about with Nomad is going back to Vault. So for those of you who are unfamiliar with Nomad, it's our application scheduler. The idea behind it is how do we allow operators to pool together the resources of thousands or tens of thousands of machines and easily expose that to developers who can then use that to deploy, update, and scale their services. Fundamentally, the way developers interact with this thing is very similar to our approach with our other tools. It starts with infrastructure as code and a declarative job file. So developers start by writing this job file, which specifies the name of their application, the resources it requires, run version 1 of this container, so on and so forth. This also includes things like CLI information, environment variables that the application needs. Now the question becomes, how do we provide to our applications the secrets they need to run? And when I say application secrets, this is things like API tokens to go and talk to S3, or database credentials to go talk to MySQL, TLS certificates to properly serve traffic. In practice, what we typically see is these are provided as CLI flags or environment variables. And the challenge with that is then they're exposed in plain text, whether in our job file or in version control, et cetera. They're sort of visible in a very obvious way. So what we recommend, coming off of talking about Vault, is to move those kind of information into Vault and make sure it's encrypted at rest and in transit and not plainly visible. The challenge then becomes to integrate that with Nomad. How does your application get access to this? And so what we see is that typically people will hard code their Vault token inside of the job file. And so it's 2 levels removed from the actual secret, but nonetheless is still a vulnerability, right? We can get that token in plain text and then go query Vault and pull out the application secret. So to try and fix this, we've now natively integrated Vault and Nomad together to solve this problem. Now, instead of providing the token itself, you provide the list of Vault policies that your application needs to be able to fetch its credentials. Nomad will then go talk to Vault, generate a token, and inject it at runtime and provide it to your application. So it no longer has to be provided inside the job file itself. Of course, this is great for our applications that are natively Vault-aware. They can read this environment variable, go talk to Vault, and fetch the values they need. But most applications aren't Vault-aware. So to solve this problem, we've brought native templating to Nomad as well. This is powered by Console Template if you've ever used that. And so you can query information both from Console that's non-secure, as well as secure information coming from Vault, and template that into a configuration file that the application understands. So now applications that don't understand natively how to speak to Console or Vault can simply use the templating and read it from a format they already understand. How does this work at sort of a high level? It starts when a developer submits their job file to Nomad. Nomad then goes and talks to Vault and generates a set of tokens with the minimum set of privilege. So the user may actually have much more privilege than the application needs to run, and so we'll get the smallest footprint of access that we can. What Nomad will get back is a single-use token. This token itself doesn't actually permit Nomad to query anything useful from the Vault. What it does is then thread this token through to the client that Nomad has scheduled the application on. That client then speaks to Vault and requests that the token be unwrapped and fetches its real long-lived token. Once the client has this token, it can finally start the end application and thread through securely the real long-lived token. And so now this never had to be provided in that job file. Of course, this seems relatively complicated, but it all comes from that single line of configuration specifying what set of policies you need, and then all of this gets hidden from the developers. The next feature I want to talk about is sticky volumes. Before I get into sticky volumes, I want to explain briefly how Nomad works at a very high level. Once again, it's going to get a little repetitive. It's to the developer submitting their job file. This job file defines everything we need to know to run the application. Nomad then uses this to make a scheduling decision to place the application on one of the available clients. The client then starts that application, and we're off to the races. Now, at some point, a developer might come around and say, I'd like to update my application potentially to V2, or maybe I want to double the amount of memory I've allocated to it. And this forces Nomad to have to reschedule the application and potentially migrate it to a different machine if there's not enough resources available on this machine. So, no, not a problem. Nomad will reschedule the application, find a new client, and move the app and start it over there. Now, this is great for stateless applications like web servers, API servers, things that don't really care where they're running because they have no particular gravity. However, if we modify this example and add state to our application, all of a sudden it's a different situation. Now, with sticky volumes, what changes is developer can come along, update the application, double its resources, change version 1 to version 2, whatever it might be. Nomad will once again be forced to reschedule it to a new machine. But what it'll do now is migrate that data before it ends up starting the application. So we'll copy the data to the new client and then start the new application and keep the data with it. Again, this sounds like it's really complicated and there's a lot of machinery moving, but all of this is masked with a single line of configuration. What the developer is really specifying to us is that they have some amount of data gravity and they'd like their data to stick alongside their application. What this will let Nomad do is then make a best effort to migrate that data alongside the app. Now, this feature is great for opening up the sort of domain of applications that makes sense to run on top of a scheduler. In particular, applications that have native application-level replication, things like Cassandra and HDFS, they're written assuming that failures will happen. And so the application knows how to replicate data around this. So if you lose an HDFS node and a new one comes up, it'll make sure the data is still three-way replicated. Similar story for other systems like Cassandra. Other software like Redis can gracefully tolerate the loss of its snapshot. All you'll see is an increased rate of cache misses effectively, but the system can gracefully tolerate it. So there's a broad range of these types of applications that are stateful but still designed to be fault tolerant in case they lose their data. And now the sticky mode unlocks those types of applications to run on top of Nomad. While security was on our mind, we decided to look back and figure out how we can secure all of the aspects of communication with Nomad. So this includes starting with the servers to ensure that the gossip traffic going between all the servers can be encrypted. It includes then the RPC traffic that's flowing between clients and servers and server to server, as well as any API traffic going to the clients or servers. So all of this is coming this month, and it'll be shipping as part of Nomad 05. We're very excited to have that out shortly. Earlier this year, we did something we called the Nomad Million Container Challenge. And what we did in this challenge was spin up a 5,000 node cluster running on GCE, and then submit 1,000 jobs, each job containing 1,000 Docker containers. And what we were able to do is launch 1 million Docker containers in under 5 minutes. And when we did this, the common reaction was, why would you ever need that? Like, whose use case is this large? This just seems obscene, right? And for us, it was sort of like hearing, well, 640K should be enough for anybody. And so today, I'd like to invite onto the stage Caius from Citadel to talk about their scale and their use case for Nomad and how they could only achieve it with Nomad.
Thank you. Hi. So I guess some introductions are probably in order. I'm Caius. I work at Citadel. And for those of you who don't know, Citadel is a hedge fund. We started in 1990. Since then, we've grown to about 24 billion assets under management on the asset manager side. And our securities side makes markets in 30-plus countries around the world. Excuse me, and is responsible for about 15% consolidated equity volume in the US. So a good size. As anyone who works in finance will tell you, speed is everything. Time to market is everything, right? So as we were growing and we were reimagining our compute platform, we were looking to scale out our infrastructure significantly. We were already using a lot of HashiCorp tools like Packer and Terraform and stuff like that, so it made sense for us to take a look at this new Nomad thing. So what we did is we set up a lot of POCs with a lot of different schedulers out there, and we had a few main requirements. The first one is we have infrastructure everywhere. We have it in lots of different public cloud providers and on-prem. We needed a scheduler that could run in any of those environments. So we had to be multi-cloud aware, right? Second thing is we have a highly ephemeral and extremely elastic infrastructure. So our scheduler has to be able to cope with large sections of our infrastructure churning, essentially disappearing, being replaced, moving around, all the rest of it. And the third one, probably most importantly, is the speed and scale. We need a scheduler that can scale at the rates, not only to the sizes we need, but at the rates that we need. So we set up, we heard about the million container challenge, and our initial reaction was, well, that's a good start. But, they're getting there. So what we did was we spun up a proof of concept for Nomad. We actually started off with a nice conservative 18,000 cores. And we kept throwing jobs at this. And the guys actually asked me, well, how long did you do it for? And the honest answer is I don't really know, but it was most of the day. So it was well over 5 hours. The only reason we tore it down is we wanted to go home. So we kept throwing jobs at these, 100,000 at a time, and we were pushing about 2,200 containers a second through the system. So that is pretty impressive. So in summary, what does this mean? Well, it means that Nomad is a pretty good scheduler, an excellent scheduler to build our next generation compute platform on. And that scale and the speed it affords us can change the nature of the compute that we do. So for jobs that we used to run overnight, our back testings and things like that, can now be run interactively almost, and on demand, and intraday. And that fundamentally changes how we can do business, which gives us a significant competitive edge. Thank you.
Thanks, guys. That's all we have to talk about Nomad today. Nomad 05 will be shipping this month. It brings with it Vault integration, sticky volumes, and secure cluster communication. So we're very excited to share that with you shortly. Now, we have a lot of other open source products that we haven't yet had an opportunity to touch on. There's all being actively developed. There's new features and new enhancements coming to them all the time. And unfortunately, we just don't have enough time today to talk about all of them. So please stay tuned. We'll be talking about these in the future. And at this moment, I'd like to invite Mitchell back onto the stage. Thank you.
Thank you. So as a recap, this is our view of DevOps, 3 layers aligning them together to work efficiently. At the top, we have development, provisions, applications. So there we're focused on delivering a microservices runtime. In the center, we have operations, Operations is focused on provisioning infrastructure, and to that end, we deliver hybrid infrastructure automation. And then at the bottom, we have security, which is focused on provisioning security policy, and for that, we're delivering application-based security. And earlier, I noted that we spent 2016 focusing on integrating our tools. So far, we've heard about SAP using Vault for security, Citadel using Nomad for scale and exceeding our million container challenge. And to showcase how HashiCorp and HashiCorp tools align all three layers of our view of DevOps, I'd like to invite Kamal from PayPal.
Thanks, Mitchell. Good morning, everyone. My name is Kamal, and I'm part of the Platform as a Service team in PayPal. PayPal is a fintech company which is innovating in the payment industry, and I hope you have seen the new ad during NFL which says PayPal is new money. So with that, there's a lot of business innovation which is happening, and the business is trying to move faster. And the goal of our team is to build a platform which is ahead of business and supports it in all scales and all needs of the business. Now, how we do that? So to just give a glimpse of the scale of what PayPal today, we built a proprietary platform as a service which enables thousands of developers building thousands of services, web application, batches, which is deployed on our own private data center, which runs OpenStack across multiple data centers and availability zones. Now, this platform is a self-service which allows developers to come, create, develop, test, deploy, promote, scale, and monitor applications fully through self-service where they need to do. And completely this is built on top of OpenStack on-prem. Now, we looked at this and he said, hey, we are good. We are able to suffice our business needs today, but are we sustainable over a period of years? Are we ready to support business innovations and things which are changing? And that led to a question, what's next? So we started looking at, from a requirement perspective, what is needed to support business and its innovation in the future. And we started as everybody know, last year when iPhone came out, it was advertised as the next big thing, and I hope today they are going to announce the next biggest thing. So the same way, technology keeps changing, and everybody is developing a technology which is better over a period of time. So we didn't want to go and adapt just a next big thing and say we solved the problem. So instead of that, we adapted a different workflow. What we did is we had the requirements, and now we started putting things saying, if we have to achieve this at a scale, what we need to do. So on the first column, we started writing, what are the problems at scale today we see? Because we are running a massive data center and we are running massive number of applications. So we started writing, what are the problems we see at scale and how these problems are going to affect our requirements. And then we figured out that to solve this problem, what is the concept or a principle you need to apply on our next generation platform? And then finally, to achieve that concept or the principle, what tools and what workflow has to be adapted. So this is how we started. And when we started doing it, we realized that when we start writing problems, it's not just the problem with the current system. When you put any new technology or solution, it is going to introduce new challenges. It is not that everything comes for free. Everything you introduce new has its own challenges. So every challenge, again, becomes another problem list or a challenge which we need to solve. So ideally, it became a graph which started growing as you add more and more. So that's where we started looking at how do we solve these problems. So I'm going to walk through a couple of examples. One thing is that we have a problem of a drift. A drift is a very simple problem. When you start with 100 nodes, and let's say that you manage it through some configuration manager, and you start applying patches, configurations, system configurations, there's a lot of things. Now, over a period of time, that may be good. When it goes to 1,000, you may have 1 or 2 nodes which is drifted from what needs to be. When it goes to 10K, it goes to 1%. When it goes to 100K, it's a large thing. And because of this drift, there's a lot of problems which happens. Now, how do we solve this? This is one of the problem statements we had. The way to solve that, we looked at it and said, hey, do we need to build a solution which is going to look at all this drift, figure out and how to solve it, or can we completely eradicate it? So one way to totally remove it is going immutable. So immutable is a very nice concept in programming where a lot of people adapted it, but building an immutable infrastructure is a hard problem to solve. But that is one of the clean ways to move out of this drift and come to a place where you say that it's a binary. Either you have this version, or it's a 1 or a 0, or you go to 0. Something very clean, and it helps us to avoid this drift. Now, how do we implement it? That's where the challenge is, right? Now, so we have to build a workflow, and we need to choose a tool which just doesn't work for 100,000, but works for 100K. That's where we started looking at a different option which is available, and we choose Packer and Terraform as a tool to provide that single workflow to do that across cloud. Even though today we are a private cloud, if you have to go hybrid, how do we do that across different clouds is a challenge. That's where we are choosing tools which helps us to do things in scale and also apply the same workflow across both private and public cloud. Another example of immutability is that once you have immutable, that means you'll be continuously replacing systems, which means once a VM is created, we never change anything from outside, which means we need to keep changing things. That means that anything running on top should be resilient enough to come back and stuff. That's where we started using cluster managers. And when you start using cluster manager, you need to know how to run application anywhere in the cluster. That's where containers came into existence. We adopted Docker as a mechanism for our packaging and runtime. So as each and every step we solved, we started adding more into the graph, and everything started growing up. And that's where layering is very important for us, that we should be able to build things in layer. For example, we treat the final infrastructure, core infrastructure, and then we build platform infrastructure, and then we have cluster manager with containers, and then you have service discovery, and then you have orchestration to do this across regions. So with this clean layering, we were able to achieve in a way that tomorrow we decide to do something, we can easily remove and replace a layer. And also one more thing is that we want to treat this as a Lego blocks rather than as a big solution which you want to take it. That's why our goal is to build a platform which enables our developers to build highly available, secure, and highly scalable application, which is something which can work across private and public cloud. And the platform, we want to build it using the best of the breed open source technology as the building blocks and provide a single workflow across both private and public cloud. And I'm really excited to be here and talk to you guys about your learnings. Thank you.
All right, thanks, Kamal. Thank you all for joining us at HashiConf. This concludes the keynote, and immediately following the keynote, I'd like to welcome Adrian Cockcroft to talk about the evolution of microservices. Thank you.